point to the other point. Rotation is always involve one axis so that you can rotate around the axis. Then mirror plane, there's always one line that anything on the left hand side will be reflected to the right hand side, but then they have the different handles. Inversion point is always invert through one point. Okay, for this example, you can see that the thumb reflect to this point, and then through this inversion point. So if an object is reflected in a mirror, the image and the object are related by a symmetry transformation. And then we write it as M, just now I mentioned. So for the mirror, we just put one straight line, and then we put the symbol of M, indicate that it's a mirror plane. And then mirror image of molecule are very common in both inorganic and organic chemistry. So the molecule and its mirror image are called enantiomers. The molecule does not have an enantiomorphic pair to exhibit the chirality. Okay, I make it simple. We have the crystal. When the crystal, we have one crystal, right? So this crystal may involve many symmetry. Okay, many symmetry. If the crystal involve the symmetry of N or bar 1, the mirror plane and the inversion point, then atom or lattice point inside this sample will have left hand and right hand. Am I right? Whenever the sample exhibit the mirror plane symmetry and inversion point symmetry, then the left hand will be converted to left hand. Then this left hand lattice point and this right hand lattice point, we call them enantiomer. Okay, this is the first scenario. For the second scenario, we have another sample. That only have rotation and translation. Let's say two-fold and three-fold. Two-fold go to this position and three-fold go to this, something like this. Okay, so if this sample only involve two-fold and three-fold and translation, that means all the lattice point or all the atom will have the same handles. If initially was left hand, then all the atom here will be left hand. And then all the atom or lattice point, if initial one was right hand, then everything will be right hand. There's no mixture of left hand and right hand. Either all left or either all right. Okay, so for this case, that it does not involve the mirror plane, it does not involve the mixture of handles, then we call them chiral structure. Okay, chiral structure. Okay, so I hope you have some idea. Whenever it's involved mirror plane and inversion point is enantiomer. Whenever it's only involved two-fold, three-fold, and then translation, rotation and translation, then this is chiral. Okay. So if this is a mirror plane, then this is left hand, then this will become right hand. And then this triangle reflect to the other triangle. And then one left hand, one right hand. All right. So if this is a fish with the left hand, then this will be fish with the right hand. And what the relationship between this one and this one? If here we have one two-fold rotation, so this fish will rotate to here. So if this is the right hand, then this will also be the right hand because this is the two-fold rotation. So when we involve the rotation, the handles of this one, the original one is R, will also be R, same handles. If this is two-fold rotation. However, if this is another mirror plane, right hand side, then left hand side again. Okay, because this mirror plane, right? Let's say this mirror plane, then this right hand side after it is mirror generated to this point, then this will be other handles. Are we clear? So this is left hand, this is right hand. So if these are all the mirror plane, let's say, so this is left, right. Then after the mirror plane, this one become left. After the mirror plane become right. After the mirror plane become left. After the mirror plane become right, left, right. So right reflect to left, left, right, left, right, left, right, left, right. Clear? And then normally we will put comma. So this is the left and this is the right to differentiate it. Okay, just now I mentioned chiral. Okay, chiral means the crystal without any mirror plane and inversion point symmetry. We call it chiral. And why is chiral important in our life? Okay, so I prepared this slide. Nearly all biological polymer must be homochiral. Okay, homochiral means that all its component monomer having the same handedness. That means that if the original atom or lattice point are of left hand, then the rest of the atom or lattice point in the particular sample are all left-handed. Okay, if the original one is a right-handed, then the other one are all right-handed. So another term that we use here is optically pure. Optically pure or 100% optically active to function. That means that you have chiral. So all left hand or all right hand. Okay, just for your information, all amino acid in protein in our body are left-handed, whereas all the sugars in DNA and RNA and in the metabolic pathway are right-handed. So in our body, we have some component with all left-handed atom. We also have some component with all right-handed atom. Okay, so if there's a mixture like 50% of left and 50% of right-handed, for this case, that is always involve the mirror plane or and or inversion point. Okay, and then for this case, we call them racemic mixture, and then the pair we call it enantiomer, like what I explained previously. So racemic polypeptide could not form the specific shape required for enzyme because they would have the side chain sticking out randomly. Also, a wrong-handed amino acid disrupt the stabilizing alpha helix in protein. Okay, you know what is the structure of garam, right? Salt, sodium chloride, and I will keep using this sodium chloride as an example to explain the structure of the simple cubic later.